Okay, greetings class. This is a lecture on Project 5.3. I want you to note that it's project and not case project. In the past you've been doing case projects, so you may go to the website and try to find case project 5.3 and you won't find it. So this is on Project 5.3. Just to make that clear. And what we're talking about and what fundamentals we're using is traceroute and calculating round trip time. So I want to first explain what traceroute is. So that's exactly what it sounds like. It's tracing a route from you to the destination that you're going to. Round trip time is the amount of time it takes to go from you to the destination and then back. And I'm going to explain what traceroute does. It uses a protocol, ICMP. If that protocol is disabled, and some people do that for security features, you won't be able to ping or traceroute to the IP. You'll get stars or request timeout. So it's not enabled on some routers by default because they have more harder security practices. So what traceroute does is if I start a command traceroute, and let's say I'm going to london.edu, it first goes to the first hop and it uses the time to live as 1 so that an acknowledgement is sent back, right? So, and traceroute will continue to change that time to live, right? So my first hop will say, okay, time to live is 1, go back and send an acknowledgement, and then it says, okay, let's change the time to live to 2. Right now, this is going to be 2. This next one is going to be time to live 1, and then it sends the acknowledgement back, and then it's going to say, okay, let's change the time to live to 3, then this one to 2, then this one to 1. And once time to live hits 1, it sends an acknowledgement back. So we're actually getting information such as the name of it, the IP address, and it'll continue to change that time to live, right, as you go on. Another thing in traceroute is it'll have the milliseconds it takes to get to that point. So you have this time to live, then you have the millisecond response time. That millisecond response time is how long it takes to get from you to that device and back. So here we go. We're going to start with the project. The first thing it asks you to do is do a traceroute to london.edu. So I've done that already. I just need to find it. I believe it's this one. So I simply typed traceroute and then london.edu, and it then starts with the response time, right, and how long it takes. And I want you to find when the hop goes overseas to London. So if you're like me, so this is the first hop in the route, right? It's my router, Schmeling router. Here's the next hop in the route. It continues to go. This one's timed out because the ICMP is shut off for that device. So based on a security feature, perhaps they do not want ICMP enabled on that router for security reasons. And then it keeps going. So you'll notice from me to london.edu is 10 hops. 10 routers are in that path. Okay. Although it does say london.edu, in this particular case, it does not look like London is in London. And you could tell from the names of these. So like you'll see that it's in Atlanta, right? And then another hop here, which seems to be the same IP address for geolocation. Another Atlanta hop, right? And if we want to, let's just say we want to verify, we could take this IP and we could open up a website and go to, you know, where is this IP address located? Right? So IP location, so we want to just do, and it tells us, okay, well this is in the United States, right? It's in Massachusetts. So it ended there, right? So I just took that last hop, that last IP address, which is the London IP address, right? And it says, I am in Massachusetts. So in this case, there wasn't any overseas hop, which is what it asked you to do. So I went ahead and did the second IP, or the second website, which was, I believe it was to Tokyo International. So let's see if we could find that. So let's close this one out. And just to show you what I did, I know that I pulled it up. I just typed traceroute or tracer, right? www.london.edu. That's all I did and hit enter, right? So that begins that traceroute. It takes a while, so I went ahead and did them before. So this one is to the Tokyo International. We can see that it has 30 hops. A lot of them are timed out at the end. And again, that's by design. Maybe they don't want you to go to that. And you can see it's going to Atlanta. And then we're starting to change right here, right? So we've got, and our response time goes up, right? 76, 174, right? So what it wants you to do is say, okay, when did it go overseas? And what's the effect? So let's just verify that this is an overseas IP address, which I believe that that's probably the first time it went overseas. Let's get rid of that. And okay, so it does go to Japan on that IP. So we've realized that this is the hop that goes overseas. So I want you to take the millisecond response time and divide it by that millisecond response time to see the increase that happened, right? So 76 divided by 28. So it's a 27% increase from this hop to that hop, right? Which is pretty significant. And then you can see as you're overseas, the millisecond response time is consistently higher, right? Well, so why is that important? Why do we care that it's higher to get from you to the source or to the destination? Why is that millisecond response time important? Well, because a lot of times people will say to you, in your business will say to you, let's increase the bandwidth, right? Let's increase the speed of the network. And basically what we're telling them is it's physics, right? The distance it takes to get from here to here will have that response time. So even if you increased the capacity of the pipe, so let's say you had 20 megs and now you can have 40 megs, so you're making the pipe wider, it's not going to increase the time it takes, not going to decrease the time it takes to get from point A to point B, right? It's still going to have that millisecond response time, right? So you can't, the round trip time is not going to change based off the bandwidth increase or decrease. So that's something that you need to understand, because if you spend money to increase the bandwidth, which just widens the pipe to make more go in and out, you still have the delay that it takes to get from point A to point B. Okay? So another question you may have in your project is to how many hops it takes to get from you to that, right? And you have that right here, so 30 hops, right? And then it tells you in one of them, why don't you try to ping one of the addresses, and what happens? So let's take this address and let's simply ping it and see what happens, right? We're not getting a response, right? So it's sending a ping. It's saying, where are you? Request timeout. And they say, well, why do you think that is? Well, as a security feature, not all things ping, right? They've shut off ICMP, so you cannot ping. They've asked you to go to, pick another site. And in this site, I picked a school in Iraq. And I wanted to see the response time there, right? And when it goes overseas. And so we're still hopping. It's still in Atlanta, right? I could see still in Atlanta, and then I see US, UK, right? We see that hop before start to go up, right? It starts to go up, and then a big delay, and then we're at consistent 97 milliseconds, 95, 95, 106, 96. So here in the US, we were 111, maybe some latency there, and then back to 111111199. But once we start going overseas, right, the hop before overseas and then overseas, you can see that response going up and up and up and up, right? And there's nothing you can do about it. So what do you think if we try to ping this? Do you think it'll work? It responded with traceroute, so do we think it'll ping? Well, let's take a look. So it does ping, right? I'm getting a response from the Baghdad school, right? It does ping. Right, and then just another feature, like if you want to do a trace route but you don't need all the information, the name and all that, and you just want something quick, you just you do a switch of -D that removes the name, right? So when we do a trace route, we don't get Schmeling, we don't get, right? It goes a little bit faster. This takes a long time, right? And it produces, what it does is resolving the name of the IP to, or the IP to the name, right? So this router is Schmeling router, right? And then this, some of them don't resolve because maybe that's by default. This is this DNS name, right? So if you do that -D, and I paused it here, if you do that -D, it eliminates the name resolution. And that's about it. You know, just go ahead and answer the questions, right? Make sure you're doing problem or project 5.3, not case project 5.3. Do some pings and see what pings and what doesn't ping. And you know, pick some sites to trace route. It asks you to trace route the Antarctica Gov site, right, to see if the cameras are in the States or overseas, right? And you can see it starts to go overseas, right? It starts in Los Angeles and goes overseas. And then I think one of them wants you to do a trace route to Australia, and it wants you to find out if it went east or west, right? And you can do that by seeing here the response, or taking the IP and putting it in a website of whose IP is this, and I just did iplocation.com, so you could do that too to figure out if your route went east or west. All right, class, that's it. Thanks.